Okay, so we're going to talk about atoms, which make up elements, and molecules, which make up compounds. And within atoms, we will talk also about isotopes. And then lastly, we're also going to talk about ions. Okay, so starting from atoms. Atoms are defined as the smallest unit that makes up an element. So say you have the atom of carbon like this, and if you take a look at the periodic table of elements that we will also talk about a bit later on, you will see two different numbers. You will see 12 and you will see 6. Yeah. So this is the name of the atom, or the symbol of the atom, which is short for carbon. This is the mass number, and this is the atomic number, which is equal to, in this case, the number of proton and the number of electrons. Now, to understand this, we first have to understand what makes up an atom. Yeah? So, at this point, we know that element is made up by atoms. Atoms are the smallest units that makes up the element. But the atoms itself, we can take a look in more detail into its structure, but at this point we will just talk about it very briefly, yeah? So atoms is known to be built by 3 components. First, we have proton, which is positively charged and has a mass of 1 AMU, where AMU is atomic mass unit. Okay? And then we have electron, which is negatively charged, but the mass is so low that it's often negligible because it's very light in comparison to protons. And the other one, which is neutron, this one is neutral, so 0 charge with also mass of 1 AMU. Now, of course, during the development of the theory behind atomic structures, so how is an atom is structured? One of the latest theories is the theory of, or the model of Bohr. Yeah, this is named after the scientist named Niels Bohr, who came up with this model. So in this model, you have, let me try to draw it here. You have positively charged protons and also neutral neutrons. So you have protons and neutrons. Let me label this. You have protons, and here you have neutron. Proton and neutron. And they both make up what we call nucleus. Yeah, so there is a nucleus, or nuclei. And in the surroundings, we have electrons that orbits the nucleus, here, negatively charged, in such a way, in a track like this, that we call orbital. So we call this orbital. Yeah. Later on, we will take a look at orbital in a more detailed manner. So we will talk about quantized energy of the orbital. But for now, I will just explain this briefly. So again, we have electrons orbiting the nucleus in orbital. So we have neutron and proton, and we have electrons. Now, atoms is a neutral entity. Yeah. So atoms overall is neutral, meaning that the number of the protons should be equal with the number of the electrons. Now, if we take a look at the previous topic, which is just the definition, if we take a look at carbon here, 6 is the atomic number, which is also the number of protons, and of course, because it's a neutral entity, it's also the number of the electrons. Now, 12 is the mass number. Since we have agreed that the subparticles that has mass are the protons and the neutrons, so the mass number is determined by the number of protons added by the number of neutrons. Okay? So from the atomic number down here, we can determine the number of protons as well as the number of electrons. And from the mass number up here, we can also determine the number of neutrons, which is in this case, of course, let's try to calculate it. It's 12 minus 6, so you also have 6 neutrons. So in carbon atom, let's write it here. In carbon atom, we have 6 protons, 6 electrons, and also 6 neutrons, with the mass of 12, and don't forget the unit is AMU, or atomic mass unit. Let's go back to the carbon atoms. Know that we have 12, 6, and we know that this represents the number of protons as well as the number of electrons, and also this represents the the mass number. Yeah. So this is the mass number, and this is the atomic number. Now, again, the unit is AMU. So it's 12 AMU, and 1 AMU is actually 1.6605 10 to the power of minus 24th gram. Yeah, so you can imagine how light this atom is. Now, in the concept of atoms, we also know isotopes. Yeah, we also recognize this term that we call the isotopes. Now, using a modern instrument that is called mass spectrometers, the scientists can provide based on experiments, so they can have experimental evidence that actually for carbon, besides 12,6 carbon, there's also 13 carbon. Yeah, so we have carbon atom that is 12 AMU in mass, but we also have carbon atom that is 13 AMU in mass. This is based on the experiments using these instruments that is called the mass spectrometers. So based on this experiment, I will try to draw it here. If the y-axis is signal and x-axis is mass in AMU, then if this is 12 and this is 13, and actually the experiment shows that you have 12 mainly, but there is also a small fraction that is 13 in mass. So we actually have both. And in this case, we have, based on experiments, we know that we have the 12 carbon around 98.93%, and this one is the rest, yeah? So it's 1.01%. This we call, these numbers, we call them isotopic abundance. Yeah, so we have mainly the 12,6 carbon, which is 98.93%, and the rest is 1.07%, and that is the 13 carbon. So the mass instead is 13. And of course, based on this, you can also try to calculate the number of proton, the number of electron, and the number of neutron. You can pause this video if you want to try on your own first. So for this guy over here, the number of proton is 6, electrons also 6, but neutron is 12.60, so also 6, yeah. While for the other isotope, yeah, so we call these isotopes. This one, we also have 6 proton, 6 neutron, but this time, 6 proton, 6 electron, but the neutron will be different because now instead of 12, we have 13 minus 6, which is 7. Yeah. So in this case, actually in nature, based on experiments, we have 2 different isotopes of carbons with the isotopic abundance of 98.93% for the 12th one and the rest for the 13th one. Now, of course, if you sum up the isotopic abundance, the sum should always make up to 100%.